Hello, I am back with more questions, and actually today is just going to be one question. It's one that I have particularly enjoyed doing. Um, the reason why I enjoyed doing this question is because it made me go to the very basics of like maths, like doing times tables and everything. Things that are very trivial, but they have a very I would say, bring a very deep insight to the nature of the question itself. So I'm going to make myself smaller so the question can be seen properly. So the question is the penultimate digit of a square or square number is 7. What numbers can the last digit be? Um, Well, whenever we think of last digits, the way we find what the last digit of a number is going to be is usually think in modulo 10. But in this case, we're thinking of the penultimate digit. So the problem becomes slightly more interesting. Now, the first thing I thought about is to list out all the square numbers from 1 to 10. And that's going to be quite important. So you have, oops. So you have the natural numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now these are going to be my numbers, and I'm going to write down the squares. So I have 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Now, what I did then is to work out if I can find an expression of the second last digit, so the penultimate digit. So I considered, let's say, 24 squared. Now, 24 squared, I already know it's going to have a penultimate digit 7 because I did this before. It's going to be 24 times 24. Now, I'm going to do this very slowly because it's going to be very important, the process I'm doing. And it's going to lead to why I think this question gave me a lot of joy doing it. So the first thing I'm going to do when multiplying these two numbers is that I am multiplying these two numbers. I know, I am doing like year 6 multiplication. I know, but it's going to be very important. And I get 16, carry 1. Now then, what I'm doing next is I'm multiplying the 2 and the 4. Crazy, I know, it's very hard. So I have an 8 down. The next thing I'm going to do is I am going to add a 0, and then I'm going to multiply the 2 with a 4, which gives me an 8. And then again you continue normally and so on. And this gives me 6, 1 plus 8 plus 8, which is 9 plus 8, which is 7. Carry the 1, and you have 5, 7, 6. Now, can I generalize this process? Imagine I had, instead of the 2, I had a P. So I have P4 and P4. P right now represents my second to last digit. So what am I actually doing? I'm multiplying 4 by 4. I'm getting I have to carry 1. Then I'm multiplying 4 by P, and essentially what I am getting is an expression. If I think of it in terms of the second last digit, I'm doing 1 plus 4p plus 4p, which is 1 plus 8p. Now, why is this important? Because notice, if my p is 2, I do 1 plus 8 times 2, which is 16, I get 17. What essentially this tells me, this expression, the last digit of this expression will tell me what my penultimate digit is going to be. And I think this is insanely cool because I did this, I derived this with like stupid multiplication. And I think, and I'm not ashamed to say that I feel very proud of doing this, despite five, not even 5 minutes, 15 minutes ago, me trying out this question, feeling very much desperate and going down to the very basics. So this is essentially what's going to happen. The first thing I do is that I am carrying a 1, which is here, this one here. I am then doing 2 times my last digit times my second last digit in in the number I'm squaring. So I'm going to write down a formula for the second to last digit um, for each of these. I'm going to call it f of p. So for one, I'm always going to get. I mean, can I get? I haven't thought about this. I know for like 4, you have 1 plus 8p, and that's fine. And for 5, it's going to be 2 plus 10p. 2 being the number I'm carrying, and then 2 times my last digit times p. And p is in this case second digit of my square. Forgive my handwriting, it's very bad. So if I continue doing this, I get the following. 4 plus 18p, 6 plus, oops, that's not 18, that's 14. And 6 plus 16p, 8 plus 18p, and I think this should be, is that correct? Yes. 10 plus, how can I write this? 20p? Yes. Now back to the digits that are less than 4. You're not carrying anything, so my last digit is going to be 0 plus 6p and 0 plus 4p and 0 plus 2p. Okay, now I'm going to have to move this somewhere else. Again, at the beginning I said that if you want to check the last digit of anything, you need to check the expression modulo 10. This is very important because this is going to tell me, for instance, I'm going to give it the same example with 1 plus 8p. 1 plus, I'm going to make this bigger. 1 plus 8p is congruent to 7 mod 10. When is this true? This is true when 8p is equal to 6 modulo 10. And this happens when p, and by the way, p can't be more than 10 and less than 0. So this is very important. it can't be less than 0 or more than 10 because it's a digit, and digits are my first 10 numbers. So P is equal to, for instance, 8 times 2 is 16. That's 6 mod 10. Then you also have P is equal to 7, because 7 times 8 is 56. No, 8 times 7, which is modulo 6 mod 10. So this is kind of the way I'm going to answer the question. So in the 8's timetable, the only digits that work are P is equal to 2 and 7. So my last digit can be 4. This works. So I'm going to repeat this process, and I haven't checked for all of my um, all of the numbers from 1 to 10, but this process shouldn't be too annoying. It should be actually quite enjoyable, because I enjoyed doing this so far. So if I check, let's say I'm going to do 5. Okay, so I'm going to redo this whole thing. I'm going to try and re-explain it and do it better. So you have 2 plus, what was it? 10. 10p is equal to 7 mod 10. What this line actually means is that for what values of p is my last digit 7? That's the way I think about it. For what values of p I'm going to get the last digit of whatever that sum is to be 7. And if you think about the, actually I'm going to simplify this. 10p is equal to 7 minus 2, which is 5. That took too long. 5 mod 10. And now notice that no matter what the value of p is in the given domain, I'm actually going to write it. P has to be between 0 and 10. That's very important. P is never going to give me 5 mod 10, because anything you multiply by 10 is essentially 0 mod 10. So we know that 5 cannot work. If your second to last digit is 7, then you can be sure that 5 is not your last digit. So this does not work. Now, if you try 6, you have 3 plus 12p is equal to 7 mod 10. 12p is equal to 4 mod 10. For those who haven't seen modular arithmetic before, the reason I can't do 4p is congruent to 1, because division doesn't work nicely with modular arithmetic. So I'm going to be avoiding that. Actually, I'm not going to be using it at all. And that's fine. So when is 12 between 12 times p between 0 and 10, congruent to 4 mod 10. So I know like 12 times 2 works, because that's going to give me 144. No, not 144. That's going to give me 24. There you go. And that's 4 mod 10. I'm not going to check all the other values, because all I need is to find one p that works, which means that I know that 6 works as a value. And I'm going to list 2 as my example. If we look at 7, so we have 4 plus So 14p is equal to 7 mod 10. 14p is equal to, is not equal, I keep on saying equal, but the correct terminology is congruent to 3 mod 10. Is 14 times p ever going to give me something that ends with 3? No, because 14, no, because 14 is an even number, and if my number ends with 3, then it's clearly not an even number. So 7, so there is no value of p. Um, actually, there's a better way to write this. P that satisfies this. This is written very poorly, but at least I hope it makes sense. 7 doesn't work. So we can move on to 8. I'm going to do that quickly as well. You have, what's the P formula? 6 plus 16p. 6 plus 16p congruent to 7 mod 10. 16p is equal to 1 mod 10. Is 16 times anything ever going to give me something that ends in 1? 1 is not, as I mean, nowhere in the 6 timetable you have 1. 3, 6, 6, 12, 18, 24, 30, 36, 42, 48, 54 and 6. No, so this is also not going to work. So 8 is also never going to give me something that ends with 7. I mean, you guys get what I mean. So if I keep on going, let me try 9. 9 was 8 plus 18p, and then 10 times 20, 10 plus 20p. 8 plus 18p, which is 7, congruent to 7 mod 10. 18p is equal to, is congruent to, this is technically minus 1 mod 10, which is the same as, because mod arithmetic is basically clock arithmetic. You're going back, you're cycling back. This is the same as 6 mod 10. And actually, p is equal to 2 works, because 8 times 2 is 16. That's one that works. So we know that 9 as a last digit works. And I'm going to cite 2 here. The last one to check is 10 plus 20p congruent to 7 mod 10. 20p is congruent to minus 3 mod 10, and we know this is never going to work, because 20 times p is always going to be 0 modulo 10. So this doesn't work. So now we are just left to check 1, 2, and 3. Now 2p is equal to 7 mod 10 is never going to work. 2p is even, so this is never going to work. 4p also is never going to work. And lastly, 6p congruent to 7 is never going to work as well. So what are the numbers that my last digit can be? And from this table, they can be, let me move this on the side, they can be, if my pen works, they can be 4, 6, and 9. The beauty about this method is that perhaps this can be extended to different like types of questions that kind of look like this. And really like the fact of how I combined modular arithmetic with very basic properties of square numbers, even numbers, odd numbers, and going back to the very, very basic multiplications. But yeah, this was a very nice question, and I think I spent way too much talking about it. Just to restate how I got this function of p. P is the second last digit of the number I'm squaring. So if I'm squaring 34, p is going to be 3. It's going to be um, the second digit of my square number plus 2 times my last digit times p. P being what I just said before. This is kind of how it's going to work. I'm satisfied. I'm not even sure if my answer is correct. Actually, I have to check that, and it's going to be quite embarrassing if I miss something out. And if I did, I'll probably put in the comments. But I'm very much satisfied of my work. I will have to check them correct though. But yeah, it seems to me foolproof unless I did something stupid. But yeah, I mean, it was a very nice question. Thank you.